All right, polyatomic ions, nomenclature. All right, this is a little bit different. I've broken up this worksheet into 3 levels. First level is pretty basic and easy, but really important. So I'm going to do the first 3, and then we'll go on from there. All right, let's see how it goes. All right, so we're working with ionic compounds with polyatomic ions. Already you should feel pretty comfortable with, single ions like potassium sulfide, where you can use the periodic table, which by the way, mine is covered up right now because the PSAs. Sodium oxide, again, single ions, making an ionic compound. Again, the most important part of that is a metal-non-metal combination. You need to know that, and we're going to reinforce that here. So how do you handle polyatomic ions? First off, we don't draw them out. We just write the formula, or we go from formula back to name. So hopefully this paper here will give you a nice foundation on what to do, and then that should be able to help you progress through accordingly. Okay, especially, I know this year we're trying to do this during the PSSAs, and since our instruction is a little bit limited in terms of time, I think this is a good way to kind of help make up for that. Okay, so let's take a look. First one here is magnesium sulfate. You're going to see again, I told you before, how many times have I said polyatomic ions are so important. Okay, so what happens is this: the first thing you do on any problem in this chapter, you think about what it is. And right now we know, and you write this on top of every one, we know that magnesium is a metal. It's on the left side of the periodic table. We know sulfate will be the non-metal component overall. So we're in the metal-non-metal, so you know it's an ionic compound. Huge, because that, as we progress through this chapter, you'll see why this is important. This is the most important step, knowing what you're working with. So right now we know the symbol is Mg. And you know it's an alkaline earth metal. You can use the periodic table for this. Alkaline earth metals want to have 2 valence electrons. They want to lose 2 to become stable. So they have a positive 2 charge. Sulfate, again, it's an ATE polyatomic ion. This doesn't help you on the periodic table. Okay? So you know it's sulfate. Mr. Parcia has 2 ugly sulfurs in his basement. SO4, 2-. So what do we see here? Equal opposite charges. EOA, this is what you want. It's already there for you. You want to eventually get to equal opposite charges, but if it's already set up as such, cancel them out. Stick it together. You get MgSO4 overall. These are the easiest. Every time you see equal opposite charges in your head, EOA, like an alarm goes off in your head. EOA, you see that? Boom, put them right together. Right away. Simple. That's why I have these on level 1. Next one. So it's MgSO4. Potassium nitrate. We know, okay, first step. What is it made of? Left side of the periodic table, it's a metal. Nitrate, nitride is the single ion. This is nitrate, the polyatomic ion, non-metal. So right now I've got an ionic compound that I'm working with made of a metal and non-metal. That is so important. Know it. Okay? And then we get to go down 2 more non-metals. It's huge. It will help you so much. So we know Kp. K. Alkali metal, one of the most reactive metals in the periodic table. Remember? Oh, let me see if I can get a potassium ring. Can't do it. Positive 1 charge wants to lose a valence electron. 1 valence electron. Nitrate. Must have, you got to know it by now. No, you are grounded to nitrate. 3 times I said no, negative sign. You should know these by heart. So right here again we see equal opposite alert. EOA, cancel them out, stick it together. KNO3 is your answer. Again, equal opposite charges, stick it right together. KNO3 is potassium nitrate. Potassium nitride is K3N, which you should already know how to do. Bottom one, aluminum phosphate. Here's your metal, here's your non-metal. Polyatomic ion, ATE ending. Aluminum, group 13, has 3 valence electrons. What's it want to do? Lose 3. That's why it's a positive 3 charge. Phosphate, I have a pond. 4. 3 ugly, that's a 3. 3 ugly frogs. Easy. EOA, equal opposite alert. Positive 3, negative 3, stick it together. Alco 4. Done. See how easy they are? Again, you know your ions. You can do this easily. This is step 1, okay? So again, you try the next 3. But again, if you don't know your polyatomic ions, you're not going to get it. So I'll give you a second, pause the video. You try the 3, and again, when you do it, metal, non-metal, write it above every one. So for sodium chlorate, give you the answer. Na plus, ClO3 negative. Equal opposite alerts, put them together, NaClO3. Beryllium sulfate, metal, beryllium, non-metal sulfate, Be2 plus, okay, because it's in group 2 alkaline earth metals, 2 valence electrons. Sulfate, SO4 2 minus, equal opposite alert, cancel them out, stick them together, BeSO4. Ammonium bicarbonate, ooh, that's a good one, metal, non-metal. I'm positive the 4 times I went to New Hampshire, I got pneumonia every time. NH4 positive. Bicarbonate, HCO3 negative. EOA, stick it together, NH4, HCO3. NH4, HCO3. All right. Level 2. Name the formula. Now, this is not going to be EOA, but watch this. Magnesium phosphate. Step 1 every time. Metal, non-metal. Simple as that. What's magnesium? Metal, alkaline earth metal, positive 2 charge, wants to lose 2. Phosphate. I have a pond for 3 ugly frogs. Now earlier, we had equal opposite charges. Now I've got a positive 2 and a negative 3. Okay, now I got to go for a common factor here. So you need to match these up. What do 2 and 3 both have in common? 6. So bring this down and watch this. You need a negative 6 and a positive 6. Well, how do I get negative 6 from negative 3? Get another negative 3. Watch. PO4, 3 minus. Negative 3, negative 3, negative 6. Here I got to get the positive 6 to get this equal opposite alert. So now I got 1 magnesium here. I need another one. And I need another one. 2 plus 2 plus 2 is 6. Okay? So now my question is this. How many magnesiums did it take to get the job done? 3. Mg, 3 right here, 3. See that? Watch this part. PO4, how many PO4s do we have? 2. So watch this. Mg3, PO4. Does that look right to you? No, it doesn't. You can't have 42 oxygens stuck to 1 phosphorus. That's ridiculous. You need 2 of these. 2 of these. Put a parenthesis in there. Mg, 3 Mgs, 2 phosphates. And again, prove it. 4 plus 4, 8 oxygens, 8 oxygens. 2 phosphoruses, 2 phosphoruses. That's why you put the parenthesis there. Don't touch that subscript. That goes outside the parenthesis there. So Mg3, PO4, 2 with a parenthesis. All right? All right, your next one. Calcium nitrate. Again, metal, non-metal. Okay? What's calcium? We know it's a metal. We know it's in group 2, 2 valence electrons, wants to lose 2. Ca, 2 plus. Nitrate, we know it's NO3 negative. Okay, do I have an equal opposite alert yet? No, you got to get one. Common factor between these two, this is plus 2, we need to make this a negative 2. This is fine as is. How do I get this to be a negative 2? Need another negative 1. How many did it take? 2. How many here? 1. So watch. Ca, do I put a 1 there? No, the symbol counts. How many nitrates? 2. So NO3, 2. 32 oxygens to the 1 nitrogen? No. No. Put a parenthesis. Again, 2 nitrates. 2 nitrates. Prove it. 1 calcium we know. 2 nitrogens, 6 oxygens. CaNO3 parentheses 2. That's the answer for that. Okay? And last, then I'm going to go over it. Oh, this is a good one. Magnesium hydroxide. This is star, this one. Star, put a big star around it. Put a big star on it. This is big. And we know magnesium is 2 plus. We know that. hydroxide. Oh no, it's hydroxide. OH negative. Okay? So now we don't have an equal opposite alert. How do I get it? We have, these are divisible. You got 2 plus down here. Need another one. How many negatives? 2 negatives. Okay, I'm going a little faster because I think you figure this out. Now watch this. This is the trick. How many magnesiums do I have? 1 magnesium. 1 magnesium. I have 2 hydroxides. This is where this is where everyone screws up. Is that right or this? Look over here. If I said this, it's wrong because it only says I have 2 hydrogens and 1 oxygen. Here, because right here I've got 2 oxygens, 2 hydrogens, 2 total hydroxides. This tells me I have 2 hydrogens and 1 oxygen. It's this. 2 hydrogens, 2 oxygens. 2 hydroxides, 2 hydroxides. Start. Another derivative of this you'll see is cyanide. Same thing. With Cn negative. Again, if I have magnesium cyanide, same idea. Mg2 plus Cn negative 2. Right? Oh, sorry. Negative 2, positive 2. And you're left with.
Hi, good afternoon, everybody. Appreciate everyone's flexibility and cooperation today.
Where do I go?
Regarding all the different activities that we're
Any
going on.
questions?
So we do appreciate
Write
that.
them down.
Hopefully everybody has everything covered.
We do.
And is ready to go on Monday.
Yes, we
And
are.
I will say this, as we get ready for the testing that takes place on Monday.
Can't wait.
Everybody's attitude determines student effort. So
That's
if we go in
right.
there, we're
I'm ready. I'm fired up.
then that's how they're going to approach it. We go in there with positive attitude.
That's right. We're role models.
And encourage them to do their best. They'll take their lead from you.
You got it.
We appreciate the fact that you're going to do that. And have a nice weekend.
You too. See? We all have to have a positive attitude about this. Okay. So 2 cyanides, 1 magnesium gives you magnesium cyanide. Again, similar to hydroxide. Be careful with that, okay? All right. So now, you can pause the video and do the next 3 like this, okay? And then I'll give you the answers right now. So you have ammonium perchlorate, NH4 positive, ClO4 negative. Did I? Oh my gosh. That's an EOA. Whatever. It's NH4, ClO4. Calcium bicarbonate, Ca2 plus HCO3 negative, becomes Ca parentheses HCO3 parentheses 2, and then Al parentheses NO2 parentheses 3. Aluminum nitrate. So again, if you have a question, let me know, but you guys should be pretty comfortable with this once you get the hang of it. Again, it takes practice, and you have a lot of practice in your packet. It's up to you to move ahead. You're more than capable. All right, so those are the first 2 levels. We're going to briefly go over the 3rd level, which I'm going to show you a way to do it, so hopefully this will help you through. Let's take a look. Level 3. And again, there's ample practice in your packet, but please ask. We will review some of this in class just to make sure. So I've got this, MgSO3. First step in anything you do, what is magnesium? It's a metal. What is this? Non-metal. Okay, what do you call that? Magnesium. Now, is it sulfate or sulfite? This subscript is so important. This gives it away. This tells you it's not sulfate because it would have been SO4. This subscript is the giveaway. It's sulfite. Well, where's the 2 negative and where's the 2 positive? They cancel each other out already, okay? This stays. That's why you go for that subscript within that polyatomic ion. That's what you look for. That's the giveaway. Because sometimes these extra subscripts at work charges disappear because they cancel out or reduce. Go for that subscript. Magnesium, again, the metal is always going to keep its name. And then you go for the ion. And again, if you don't know your ions, you're not going to be able to do this. But pretty much all of you know them. So you guys are going to do really well. Okay, next one. NaOH. Okay. First step always, what is this? A metal. What is this? Non-metal polyatomic ion. What do you call that? Sodium. We know that already. OH. OH. Oh no, it's hydroxide. And again, remember last level we did with the parentheses too? You don't need that here because this is a positive 1 charge. This is a negative 1 charge. They already cancel out. Okay? So again, they cancel out and the OH is your answer. Alright? Okay? Next one. K3PO3. Alright. First step as always, don't start until you do this. I don't want to see anyone without this above it. That has to be written on your exam. Everywhere you go, I better see NM, NM, or MNM, or I will take points off. This has to be done. So now we've got right here potassium. Where did I say to go? Right here. This subscript within this polyatomic ion is the giveaway. So if you already have, if you know these, which you know all 25, you know that PO4 3 minus is phosphate. 1 less is phosphite. Potassium phosphite. Done. Again, that's the giveaway. That, you go right there first, you know what that is. Okay? This, look here if need be, and then that. Done. So simple. And then the last one. Okay. Now, this looks like a bit much, but it's easy. Again, watch this. Metal, non-metal. You better have it up above. And if you don't have it in your packet, you better go back and put them in your packet. Okay, because when I check a random page and I'm seeing these missing, you're going to be losing points. And I know it's annoying, but it's reinforcing a message. Metal, non-metal, ionic compound. And again, you'll see later in this packet, 2 or more non-metals, covalent compound. What's this called? We already know. It's called beryllium. Okay, where do we look? Here or here? You got to look here. This is the giveaway. This came from the charge over here. This came from the charge up here. Don't worry about that. Worry about this. PO4, phosphate. Done. If it was BE3PO3 parentheses 2, it would have been phosphite. Okay? But again, that's the giveaway subscript if you're unsure. Look there, you'll know the name of the metal. But if you're unsure, look at that subscript right within the polyatomic ion. That's the giveaway. That is the giveaway. Okay? Because we know with, again, you know, since you memorized them all, this is common. The charge is the same. This is different. So if you go right to here, and you know it, which most students, not all you do, that's the ion. That's why you go phosphate. Okay? This would have been phosphite. Alright? So get her done. Move through the packet. Again, race to the top month. Alright, good luck. Get working on it. Let's go. We're not stopping.